Hello and welcome to another session in mathematics. In this session we'll be looking at matrices, plural matrices. But before that, let us take a review of our previous lesson. Welcome back. Today we'll be looking at the definition of matrix and notation of matrix, and then we'll look at types of matrices. Okay, so let us start with the definition of matrix. A matrix, plural matrices, is a rectangular array of numbers enclosed by a pair of brackets which is arranged in rows and columns. Like we have A, B, C, D. We have something like this, and then looking at this, we call it what? A matrix, where line A, B and line C, D is what we call the rows, and then we call these columns. Okay, so looking at this matrix, we say it's a 2 by 2 matrix. A 2 by 2 matrix, written as 2 times 2, but we pronounce it as what? 2 by 2. Okay, if we have matrix like let's say 1 2 3 4 5 6. Now remember, these are the rows and these are what? The columns. So we pronounce the row before the column. We say the row before the column. So how many rows has this? It has what? 2 rows, and then column how many? 3. So we call it what? 2 by 3 matrix. 2 by 3 matrix. Okay, so let us now go over to the order of a matrix. The order of a matrix is just what I just said. Like in the previous matrix, we say that it is a 2 by 3 matrix. If we have a matrix of the form A, B, C, D, E, F, G, H. Now this matrix will count the what? The rows 1 2 3 4, and the columns are what? 1 2. So we say it's a 4 by 2 matrix. Okay, then if we have 1 0 3, we have let's say 4, then we have 3 0 2 1, we have 1 1 1 1. For instance, this is called 1 2 3. How many rows? 3 by how many columns? 1 2 3 4. So we say it's a 3 by 4 matrix. So that's just the order of what? A matrix. Okay, let us then go over to the types of matrix. Types of matrices. Types of matrices. Okay, the first type is what we call square matrix. Square what? Matrix. A square matrix is a matrix in which the number of rows is equal to the number of columns. It has what? Equal number of what? Rows and columns. For instance, we have 3 5 and 1 0. This is a 2 by 2 matrix, and it's called what? A square matrix. If we have 1 2 5 3 0 1 5 0 3. Now what's the order of the matrix? How many rows? 1 2 3, columns 1 2 3 is a 3 by 3 matrix. We call this matrices what? Square matrices. We can have 4 by 4, 5 by 5, and so on and so forth. So we call them what? Square matrix. A matrix that has equal number of what? Rows and columns. So let's go to number 2. Number 2 is what we call row matrix. Row matrix. Row matrix is a matrix that has exactly one row. For instance, we have 3 5 7. How many rows does it have? Just one. We can have 0 3 2 1 7. That's what? One row, and we call it what? Row matrix. Okay, we have the column matrix. Column matrix. It's a type of matrix that has exactly one column. Can have something like 3 5 7. Can have let's say 0 3, 2, 4. These are called what? Column matrix. Exactly what? 1 column. Okay. Number 4, we have the null or zero matrix. Null or zero matrix. The null or zero matrix is a matrix that has all its elements as 0. All the elements are 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. You see, we call this what? A zero matrix. It can have a 4 by 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Any matrix of this form, this is 3 by 3, and this is 4 by 4. Any matrix of this form is called what? A zero matrix. Then number 5, we have what we call diagonal matrix. Diagonal matrix. Okay. A square matrix is said to be diagonal if all its non-diagonal elements are 0. Or its what? Non-diagonal matrix are 0. Like if we have let's say 2, 0, 0, 0, 3, 0, 0, 0, 1. Okay. Looking at this matrix, the diagonal here includes 1, 2, and 3. Okay. So every other thing apart from these ones that are on the diagonal are what? Are 0. We call this what? Diagonal what? Matrix. For instance, we have a 2 by 2 matrix where we have 0. For instance, if we have a 2 by 2 matrix where we have x 0 and then 0 y, the diagonal matrix is formed x and what? And y. Okay. Number 6, we have what we call unit or identity matrix. Identity matrix or unit matrix. Okay. A unit matrix is a square matrix that has 1 as elements in the main diagonal and zeros elsewhere. If we have 1, 0, 0, 1, we call it what? A unit or identity matrix. If we have 1, 0, 0, 0, 1, 0, 0, 0, 1, we call this what? A unit matrix or what? Identity matrix. It's a square matrix that has 1 as what? Element in the main diagonal. This is what we mean. Okay. Then we have number 7. Number 7, we call it singular matrix. Singular matrix. What's the meaning of a singular matrix? A singular matrix is a square matrix which does not have inverse. A square matrix without an inverse. Number 1, the condition is that it must be what? A square matrix without what? An inverse. Okay, so when we proceed, we will know what we mean by the inverse of a matrix. Okay, probably in our next class we'll deal with inverse of a matrix, so pay close attention. Then number 8, we have equality of matrix. Equality of matrix. Two matrices are equal if and only if they have the same order or dimension. If they have the same order or what? Dimension or order. Okay. And each element of 1 is equal to the corresponding elements of the order. If we have A to be equal to, let's say 4, 3, 8, minus 1, 6, and minus 2, and we have B to be equal to 4, 3, 8, minus 1, 6, and minus 2. Looking at this, we say that these two matrices are what? Are equal. So A is equal to B. Do you understand? And the condition here is that the order of the matrix must be the same. This is 2 by 3, and this is 2 by 3 also. The number here is the number here, the number here is the number here, and the number here is the number here, and so on and so forth. So we say that this is what? Equality of matrix. Then let's go to the last type. We call it conformable matrices. Conformable matrices. conformable. Two matrices A and B are said to be conformable matrices when the number of columns of A is equal to the number of rows of B, or vice versa. That is to say, if A is equal to let's say 2, 3, 5, 0, and then we have here to be minus 2, 4, 3, and 2, then remember the order of this matrix is what? 2 by 4, right? Then B is equal to, let's say, 2, 3, 4. We have here to be 0, 1, minus 2. We have here to be 5, 9, 3, and then we have 1, 0, 1. Okay, what's the order of this matrix? The order of this matrix is what? 1, 2, 3, 4, 4 by 3. So we say that what? A is conformable to what? To B. It's because A has what? 4 columns. 1, 1, 2, 3, 4. And then B has what? 4 rows. 1, 2, 3, 4. Okay, we say that two matrices are conformable when the number of columns in matrix A is equal to the number of what? Rows in matrix B. Do you understand? And vice versa. So the number of columns in matrix A is equal to the number of rows in matrix B, and number of rows in matrix B is equal to the number of columns in matrix A. Then we call them what? Conformable matrices. Okay, thank you for joining us in today's class. I hope you really understood everything we did. So to refresh your memory on what we've done, kindly provide the answer to the following questions on the screen. Welcome back. So far we've been able to define matrices, and we've taken the types of matrices. So we'll stop here today. In our next class, we'll go over to addition and subtraction of matrices. So do well to use the lesson note on the platform for better information on what we've just done, and feel free to leave your questions or comments on the comment section. Till we meet again in our next class, stay safe and bye.